Okay, so okay. I kind of like the music that is playing. Okay, let me. So I you know I yesterday we were doing the same thing, um, but the stream unexpectedly ended, and also I made some errors. So I went to fix those errors, like also using the stream software. It is kind of new to me, but I think when time passes, I will be able to use the software. Now I don't know what has happened. Okay, okay, yeah. So yesterday I was saying something before. I was saying something before the stream ended, and I was talking about the dependencies. Yeah, I was talking about the dependencies. So I kind of realized we could do something. Since this is not an advanced system, so let me just maybe recap what we did. So we were trying to abstract away the type of database being used, yeah, like used from the client itself, yeah. So we created in our interfaces, we created an engine interface and an engine client interface. So we have the general engine that has literally nothing, and then we have the database engine. Now, our database engine has these methods there: query, insert, delete, and, and update. So the whole thing is, why do we even have a database engine? Um, Now, the method I wanted to use yesterday, and I'm still going to use, is we should have an engine client, and this engine client should be the one that is exposed to the users of the engine. And the example I gave was, let's say you have MySQL database. Yeah, you have NoSQL databases, for example, MongoDB, and some SQL databases like S, Postgres. Yeah. So now, um, if you create an object to wrap the MySQL database, and then use that object, which of course we did in the previous study smart that I okay yeah this the previous study smart. It was like a database manager, but then this database manager exclusively managed a MySQL database. So the clients, one way or the other, knew what kind of database was being used, and they could request the last query that was run to see if there is anything that they could do with the last query. So now I was thinking, what if we have an engine client that is something that uses an engine? So we can have the MySQL engine, we can have the Postgres engine, we can also have the NoSQL engine. So these are different engines, yeah. And then the engine client now is the database manager. So whenever you create an engine client, you need to plug in the type of engine it uses. Um, so that means we can change the database engine during runtime. Um, so you could have the same database manager, but then having multiple engines or different engines being used at different points in time. And this means if there is any changes, we don't change the engine client, we don't change the users of the engine, we only change the engine itself. So now the users don't really know which databases. The users, I mean, the different engine users. Like maybe you have a product class that's supposed to insert something into the database, or you have a user class that's supposed to log in. these different clients do not know what is under the hood. They do not know which database the data is being persisted on, because the only thing they see is the database engine client. So that's why we have the engine client. So we have a specific namespace. Yeah, so these things are following the convention of the ZAS. So the engine client uses an engine. Yeah, so that was it. So that was the recap, and then we had abstract classes. So the abstract class, we had an SQL engine. Now this abstract class, we're going to have maybe two abstract classes. We will have no SQL engine and SQL engine. But for this system, we are really using only the SQL engine. So this SQL engine abstract class um, has something that is common to all of the SQL databases. Yeah, things like Postgres, SQL itself, um, which one again? MySQL. So they are all, engines that are SQL engines. So we have an abstract SQL engine that implements the engine interface. Yeah. So now one of the things that all of these engines have in common is the connect method. And for us, we are using PDO, so we can change the driver. Then you can see the driver here is variable. So the only thing now we have to customize is the driver we are dealing with, and maybe the ports, etc. So that's the abstract engine, and then we have the concrete engine now, which is in the classes folder. So abstract classes are placed in the abstract folder, interfaces in the interface folder. Now we have concrete classes are placed in the classes folder. So here, maybe you could call them modules if you want. It's up to you how you want to configure your ZAS. So if I have now the MySQL engine itself, this is the MySQL engine. This MySQL engine extends the abstract SQL engine. And for you, maybe you could have other engines like Postgres, etc. Now, so I've been thinking about it. I didn't want to put this data here, but this is just a simple system. We don't have to worry about the env file right now. Yeah, or some configuration file. Yeah, that's why I just put it here. And I'm sure, based on the way we are building the system, if you want to abstract this thing away into an env file, it will be quite simple. SQL databases, yeah, they have columns, they have tables, they have a condition string where you want to get something from, etc., and a condition value. So now these other remaining ones, they are really mainly for the SQL database itself. But I was thinking, now let's fool the system. We can fool the other clients of the database that they are all using a structured database, yeah, like a structured query database or structured something like that. So instead of using an array of parameters, which will be harder, because if we put an array of parameters, that means we have made the clients aware of which database is running under the hood, or which engine you are running. Because if this guy is to do delete and then he sees that the parameters of the array should be table, condition, string, definitely the user class will know that, okay, I'm dealing with an SQL database. That's why I'm having things like table XYZ. So I kind of want us to redo something. We will say every database has a container, every database has column, and they have values, etc. So the different databases. So let's say if you are dealing with a NoSQL database, documents can correspond maybe in MongoDB. Documents can correspond to, it's up to you how to parse those things in the engine itself, so that the engine now is responsible for parsing the arguments to become more specific to itself. I know this might pose a bottleneck maybe in the future, or let's say really the different databases that you want to use, and then they are having really different concept of storing data. It becomes really difficult to map one to one what is a table in some type of database, or what is a column in some type of database. But for now, we can just use that. um, we are going to say every database has these parameters here, these ones here, a table, a column, a condition string, condition value, and this articles will only be really used by SQL engine. So I'm thinking, if I can how can I abstract this articles away? Now, the main reason the articles were here was to allow the queries to be more flexible. But now, since we are having a common type of database, like an or database that is overlaying the underlying database, we will have to get rid of the articles. Yeah, we will have to get rid of the articles. Fetch all can stay there. So fetch all means, should we get all of the rows, or should we only get the first one that matches the. So it will be like, yeah, fetch all equal false or equal true. But then the one for articles, I'm going to remove it. So it's gonna be some little hell of a work here. But then let me just go to where it's not gonna be some work. It is gonna be some work. Whew. Good. Okay. So the first place we have to start from is the engine itself. So what does the engine say? The database engine. So this is where the whole params, an array of params came from. So we want to change that. We want to make it to be more like this. Yep. So they'll all just follow this particular pattern. So we're gonna have for query, I'm gonna take all of this. Things are gonna become red. I don't like to see red lines, but refactoring the code. Yep. When I look at the amount of work I have to do to refactor this thing going upward. Okay. Can I give it a better name than this? Table, instead of table I can call it container. Yeah, probably. Yeah, maybe I can call it container. I don't even know if people can hear me. Let me. Yeah, I think people can hear me. Yeah. I am guessing that you can hear me. Okay. Yep. So let me just do this thing really quickly. I wish I could speed up things here, but seems like no. I feel like I have to do some update here. Instead of saying condition string, I can do an array of columns the same way for, yeah, yeah. Now the thing is, hmm, hmm. Okay. Now I'm still thinking how to make this thing portable across multiple databases. So if you say I should update the condition string, huh, ha, what's the best way to abstract? Like looking at this, I can see it kind of needs a whole new designing uh, technique. Like there's a whole like a whole new design technique I have to use here. Or probably I have to go look for some design pattern. Um, hmm. Okay. Seems like there's not there's not an easy way to totally decouple the database in use from the actual object we are dealing with. So what I'll do, I'll just maintain the one that I had previously. Yeah, I'm going to maintain that, and let me see if we have made any changes here so far. So I'm just going to do git stash. Yeah, thanks to git. Okay, so I've decided to leave it like that. So what now we will mainly be focusing on is this specific type of engine that we are decoupling. So the way the query is passed, like I really don't want the way the query is passed to like to affect when the engine is changed. Yeah. So what if we leave from MySQL to NoSQL, not NoSQL to Postgres SQL? The changes, because definitely the parameters of the function poses a very high coupling behavior um, between the the clients of the engine and the actual engine itself. Not the clients of the engine. I mean the people who the users of the particular engine we are talking about. So if it is Postgres, I cannot believe that there is a better way to structure either the parameter, or should we use things like huh, if you look at the way databases work, it is difficult. Maybe it was like something like a keyboard, for example. It's easy to abstract the way the keyboard we are using. Maybe we can use maybe a service provider pattern. But I'm thinking, how can a service provider pattern help here? Like my goal is to structure the the parameters in a way that they reflect little to no um, little to no uh, behavior of the engine underneath. So what I'm going to do, I'm going to I'm going to, let's say, let's go to, we can look at similarities. Let me see. Between my SQL and, not even my SQL, between SQL and NoSQL. It seems like I'm not getting the right query. Okay. Let's say we have a Firebase database. Yeah? Select, I want user with ID or whose name is Levi. Or I want Yeah. So selecting, maybe we can use, what do you want to select? I want to select this, and this. Um, from where? So selecting from where? Uh, select from where? Then what else? Let's say where. So the condition. Yeah. Now the condition can have multiple. The problem with the condition is the fact that it can be separated by and or. The condition can be separated by and or, different parameters. So now this thing needs a lot of thought. Given that the condition can be separated by multiple parameters, not parameters, multiple operators. I'm saying parameters, multiple operators, logical operators. It could be where this is this and this is this. Where this is this and this is this, or this is this. Where this is like So I'm thinking, does that mean we should create? We should we should create a condition object that can allow you to put conditions together. Yeah. So this is this and this is this, or this is this, and then we pass that condition object. We pass the condition object to the query we're making. Wow. Let me see. Because I kind of want the condition to be as flexible as possible. Okay, so what have I established so far? Let me get a whiteboard. I didn't really want to give a thought, too much thought to this thing. But now it seems like I'm here. It's okay, I'll just agree. Okay, let me just do. Which email can I use here so that it doesn't okay. So we can have condition this link to another and condition this and then all of this condition here is linked to another condition with an OR. Then this one has some XYZ condition. But yeah, so then probably I would say all in all we can have the container from which we are trying to get the data. The data we want to get, their column name, column, maybe we'll call them column or keys, I don't know. Yeah, column or keys. These are arrays. So then we want the condition. So select this, select from this, or maybe select this from this, or select from this. We can put the table here, right? I think it makes sense. Select from this table. You know, now I'm thinking of coming up with my own query language. For example, imagine the table we are selecting from can be another condition, so that if we see things like end, select this and this, then we know that we are talking about intersection. That is join, yeah. If we see or, then we are selecting both of them union. So this one is intersection, this one is union. So we can have things like maybe inner joins here, and here we can just have maybe join. Do we have to have join? Something like that, or anything that will give us an OR operation, such that when it exists in one of the tables, but then you have to return from which table it exists. This can tend to get complex, but yeah, this would be interesting though. We can have the table name being a condition. Yeah, that sounds cool. So then what else can we have? Then we can have maybe so we now have, what do we want to select? We want to select these keys from this table, which is a condition. So the condition will determine whether it is an intersection we are trying to get, or whether it is a union. Yeah, so we can only have intersection and union here. So all of those other joins, now how do you support those other joins? Now if let's say we were to write a framework, yeah, but probably I will have another section that just merely give you access to raw queries, even though, yeah. So now that means whosoever is using that particular application will make their application clients aware of the type of engine. Like I'm sure there are components in applications that have to be highly coupled to the underlying database engine, yeah, that is being used. But now for just a general case, you can just have or and end, and then from where. So this is going to be the table or the container or containers. Then another one here talk about where, and then we have condition. So now our condition is split into two. This will be column this, column that, but then we then have to have the condition values, yeah. What value will go for every condition, okay. What value will go for every condition? Now I'm thinking, can we make this even cleaner? You know, condition values. because if you put condition values here, there must be one-to-one mapping. There must be one-to-one mapping between the condition and the condition value. So like that means you should remember the position. So let's say positioner, yeah, it is positionally important. So what if we could just put both the condition and the value in a single condition tree? Yeah, so we can create a condition tree that has an object, and then the different engines will decide how to use the condition object. That's solved. Okay, there's something else to work on. Now I'm thinking I'm going to work on it. So okay, then let's say, so this one, if you put options here again, it will further, will it bring coupling, so that for stuff that I like, for clients that I highly coupled to the engine, they can pass different options here, and then the engine itself will know how to handle those options. And then we can have a construct function that has 5 parameters. Now I'm thinking, can we reduce the number of parameters? Okay, no problem. I don't want to make this thing like a state machine, because you could do method chaining. I think I did something like a state machine in one of ZAS's function. The good thing is I can see ZAS in here, so I can see ZAS in VS Code. So let me look at it. There's this thing I did in one of these classes that I have to split up sometimes in the future. This ZAS helper is too big, like it's very big. I need to split this thing up. I will do that. But for now, the guy does the job. Let me. Yeah. So something like this, you can see maker, and then we have the in function in this particular directory. Make this. Now this can work, but it's something like a state machine, where the in will set the state of the particular maker, and then the make will use that state. But I don't want this one to be a state machine. I don't want the one we are working on it to be a state machine, So we can just pass everything we need every time we need it. Yeah, this looks cool. So now it's time to write the tree, the condition tree. So it's gonna be a data structure, and it's gonna have how should we make it? Should we make it a linked list? Now for linked list, we have to keep track of the tail and the head. Okay. Okay, now this thing is getting even cooler. So we are about to design a condition data structure. So it has, should it be a binary tree? Binary tree insertion is logged in, and really this thing, I don't think insertion matters. It's just trying to link different conditions together. But then the problem is, a condition can be in a group, and then that group can be linked to another condition. So you can have conditions in here that are in a group, and that group then is then linked to another condition and is in another set of group by an operator, either and or not. And or not. Okay. So I'm gonna do. I'm going to think about this structure so that I come up with the most efficient structure that will cover up as much condition as I can, and or not. So not this is equal to this is equal to this. Now the not operator has the not only takes a single yeah, it takes a single condition. Okay, so now I'm going to give myself time to think about this condition data structure. Like, this thing's supposed to just be something simple. I just want to go ahead and kind of ignore, because like literally I've not coded anything today. I've not coded anything today. Not at all. So I'm thinking this is just to, okay, you see, I'm supposed to be here just refactoring a particular code, and here I am thinking about extreme decoupling, and if I then get the extreme decoupling, probably I might. Okay, you know what? Let's not make things complex. We know that this particular system uses no SQL databases and SQL databases. So with that, let's just use that particular to write the system. But I'm actually going to write the condition data structure, so that then I can write a manager for that particular data structure, so that I can be able to put conditions in that particular structure and in the easiest way possible. Because I'm thinking, like, say you're going to create a new condition object, and I'm thinking if there's a format I can just use that will automatically lead to a structure being created. So maybe there is a condition parser that can parse the condition, and that will just be something even complex. But for bigger systems I'm going to work on, I'm definitely going to use the condition in there, so that we have a really maintainable. But then if the system is too big, it becomes harder to learn, but then it's easier to maintain. If you have too many classes all around the place, things get really confusing. But so far so good. I'll take it from here like this. I'll take it from there like that, and kind of, yeah, not worry. I won't worry about the extreme decoupling. Yeah. So let's just assume this system is like this. Yeah, we use MySQL and NoSQL database, but it's okay. Yeah. With this said, we have managed to implement the SQL engine. We have managed to implement the SQL engine, guys. This SQL engine, I'm not going to touch it, but for that condition thing, the next project I'm doing, I'm going to sit down and write. I don't want to make ZAS Environment a framework, but I will make it a package. Probably when I write the best one, I'm going to make it a package, and yeah, people can include that particular package into their application and use the condition data structure. Yeah, I think that makes sense. Yeah, and this whole thing about the database decoupling from the application, I'm going to research on the best implementation thereof and even try to improve on them. So if I can write a better abstraction of databases, I will also make that a package. And now when I make all of those packages, then probably I will then go on to start a framework and make it open source. People can, because I don't like things that have a lot of memory footprint. Even though I want middlewares, but uh, until the need is there, so it's like plug and play. Yeah, if you need it, you plug it in and go. Um, so if I will ever make a SaaS framework, trust me, it's gonna be really lightweight, and as fast as I can make it. And security for that one is a default thinking. Yeah, it's just part of the thought process. So I'm going to leave this engine like this, and then we can come now to the engine client itself, the database manager, which is an engine client. So you can see our database manager is an engine client. So yeah, see, all it does is that it just you give it the engine you wanted to use, and it sets that particular engine. Um, a new database manager of this engine. Okay, can you get the engine from a database engine? No, you can't get the engine. Why do you want to do the engine? You want to use the engine for your own? You want to to put the engine in another thing? No way. Wait, we could. No, okay, let's say you have two database manager and you want them to use the same engine. That would be cool, but for it's not in our use case, so let's leave it like that. Yeah, the only thing we have here is an engine interface, and we can set the engine of the database manager. Now I'm thinking of a more convenient way to do it. Should we pass it up in the constructor? Because we don't want to do this thing in 2 lines of code again, but yeah. So let's say we can pass it into constructor. Engine, and we can just say and now if we are using the engine, yeah, we know, okay, we are using this particular engine, but then the engine client must have a way to access the functionality of the underlying engine, right? So now, instead of just saying implements an engine client interface, it's better we say there is a database engine client itself. Now then the database engine client um, will be a type of engine client, the same way we had the engine and we had the database engine. The same way we are going to have the engine client and then have the database engine client. Yeah. So we're going to use ZAS to make that. Let's use ZAS to make that. So we say PHP ZAS make. Now it's going to be, it's an abstract class. No, it's not an abstract class, it's an interface. Make interface. And this is in the engine client namespace. PHP ZAS make interface engine client. Database database engine client. Now I don't know if you're getting what I'm saying. What I'm saying is, you see, you have an engine client, but the engine client must use the underlying engine. However, this engine client is actually a middleman between the user of the engine and yeah, between the users and the users of the engine. So what I'm saying is, you want someone to go between the to go through the manager, which is an engine client, before they get to the engine. But then if the manager itself doesn't know what the engine offers, it the manager serves like a face for the engine. But then the underlying engine can change, yeah. So now that's what we are trying to do here. we want the engine client um, to have a specific database engine client, the way we had a specific database engine. So a database engine client uses the database engine, and then we can have the abstract, yeah, the abstract SQL engine client. Then the abstract. Do we need an abstract SQL engine client? No, we don't need abstract SQL engine client. So if we need it, we'll fix it. We'll make it. But for now, we just need to have our DB manager um, to be an actual database engine client. So maybe we can say from this point onward, we can go ahead to say that we can use different type of engines, yeah, SQL engine, um, or yeah, so that the database manager is not a specific type of engine client. So it's just a general database engine client. They can work on NoSQL databases. They can also work on SQL databases. So that said, yeah, let's make this PHP ZAS make interface engine client, database engine client, um, and this actually extends our engine client, engine client, engine client. So there's the namespace here. This one here is the namespace, and this one is the actual engine client interface. So I could put engine client interface here, but I'm not doing it, and I don't have that much time to write all of that. So with that, then we can just go ahead and make this thing. Yeah. So we have the database engine client. So we have database engine client interface. That's the actual name. Okay, so then in interfaces we can go for our database engine client. Yep, here we go. Now this database engine client is the one that uses the database engine itself. So one way or the other, now I'm thinking, what can I do right here? I'm thinking of the best way so that I don't have to rewrite the you can't have an engine client that is of a type engine. Doesn't make sense, because I was thinking of having an engine client that is of a type engine, so that I can have access to those methods in the that are in the actual engine itself, the database engine. Yeah, these ones here. So I'm just gonna copy them. Thank God they are not a lot. So this is mainly to make the database engine client interface, yeah, aware of the behavior of the engine is running. Okay, now I'm thinking again. I don't want to go duplicating code, such that whenever there is a new functionality added in the engine, it is also added in the engine client. Okay, I don't want the engine client to be of type engine. Okay, sorry for that, okay. So, this little break, I've thought of something. You see, you don't want to be duplicating code here, right? No one wants to duplicate code. For me, I really hate duplicating code, because now if there is any changes to the engine, you have to come and change the specification, the client. So since we have one thing in common, we have an engine. The engine has a specification. What is common to both the engine user, and the engine itself is the specification. The user of the engine uses the engine based on the specification or based on the manual, and then the engine itself implements what it's in the engine specification. So that leads us to another set of abstraction. This would be called engine specs. Yeah. So there are different engine specifications in here. Engine specification is in the engine namespace. So I'm going to say PHP ZAS make interface. This is an engine specification. It's in the engine interface, but then in the specification, engine specification, and so in the engine namespace, in the specification namespace, we have the general specification. But do we need to have general specification? No, there is no general specification. Yeah, there's no general specification. You can say those who are no, there's no general specification. I don't think so. There must be particular specification. So if you are a database engine client, you want to extend that means you want to know about the database engine specification. You can have an engine specification. There is no common thing in an engine specification that people should know about. What is it? Get engine specification? That doesn't make sense. No one wants to use engine specification. So I'm just going to start with something more specific. One, we want a database engine specification, and then database engine specification. So in specification, we're going to have database engine, specs, so a database engine specification interface. Whew, very much long name. Welcome to object-oriented programming and the naming convention. There we go. So right here we have the specification now have been created for us, and we have the database engine specification interface. With this said, we are going to make some modification to our actual database engine itself. So we are going to abstract away this particular set of code. Control C, and we're going to put that in our engine specification. That makes sense, eh? Then we are going to recreate the database engine itself, but this time around it's going to be using the engine specification. So we're going to say make interface engine, and then it's going to be database engine, ENGINE. So we're going to make a database engine that extends two interfaces. One, it extends the engine interface, so it extends engine. Now we have to put the namespace, else it will start from the root namespace. Engine, and it also extends engine. So when you do -e, everything that follows is the list of extended interfaces. Engine specification. Which specification? There's the database base engine spec. Yeah, those are the two things we are going to extend. But then we want to do --f so that we overwrite the current database engine. This won't make any change to our other stuff, so don't worry about it. So there you go. Exactly, this is it. So here we have our database engine that extends database engine specs interface and the engine interface. Yeah, with this said, and we are using engine specification, database engine interface. Okay, even though we are in the same namespace, I think we should not even have had engine here, but it's okay, no problem. Okay, with that said, let's see. So this should actually cause no problem to our database manager class, because after all, it is still okay. No, we have to rework on the database engine client. Yeah, you know, sometimes you can lose your train of thought if you are looking at all of these things from yeah. Look at this thing. It has basically it has. Let me just comment. Yeah, database engine interface. And then, funny enough, like, you know, what is even funny is the way we are creating all of these things just to abstract. Okay. Now we have our engine. Now we want the engine client. Is the database engine client now that is going to not just extend the engine client interface, but it's also going to extend uh, the engine, yeah, engine in the database engine specification, so that it knows the specification we are dealing with here. So we are going to be making our interface in our engine client. And this time around, we are making our database engine client interface that extends the engine specification, and then it also extends the what's the name, engine client, yeah, engine client / engine client, like that. Yep. --f PHP ZAS make interface engine client database engine client extends engine specification database engine specification. Also, now the one thing you should notice that if we use -e here, everything here will have interface appended to them, so don't worry about that. Yeah. So that's good. That means we know the specification we are dealing with. Yeah. We know the particular underlying specification of the database. So now that means our DB manager should have some errors. Wait, oh yeah, it has not extended the database engine client yet. So I'm going to say PHP ZAS. Let's clear this thing. It's become cluttered quite quickly. So these are the things I'm saying. PHP ZAS. No, I was thinking if there's a way we can just group the namespace. For example, I say in the engine namespace, I do that. Then put all of the things I want to put in here. PHP ZAS make something, but I will see about that. Make now this not it's a class. Make class DB manager. And DB manager class, it's in the root. Is it in the root? No, it's in the engine client. And it's an engine client. Engine client, DB manager, and it actually implements the database, the engine client, database engine client. Yeah, that's all. So, and we have to do dash dash f to overwrite. Now here comes another error I've seen. Okay. The thing about this ZAS updater is it does not recursively check like if you say you want to implement this particular interface here, it doesn't check whether that interface implements another interface that implements another interface until it reaches to the root. So I don't know how I can implement that such that we are able to pass this particular code up here and then follow the actual path we are dealing with. I don't really know, but yeah, so far this is what we have. Engine client DB manager does not implement query, insert, delete, and update, and also set engine. So we have to implement all of that. Ooh. Okay. Let me see if we can have an extension that does that for us. PHP I can just search it. Let me see. I'm actually going to search if there is anything here. I can say PHP or VS Code extension to implement interface function PHP. Okay, painfully ZAS could not even help us here. We now have to go for these methods and implement them on our own. Okay, let me just say public function. We have set engine. Thank God. So set engine, we know that we are going to have our private so this we just have to make it a database engine interface. So you don't come set an SMS engine here. and you can actually pass in our database engine interface. And then we can then say okay, we're going to be implementing them one by one. Public query, just like that. We're going to be calling this engine query. Passing our params. So we are returning our public function update. We'll be returning this our underlying engine. Gonna be updating with the same params. Public function query. Let's hit insert. Yeah, we'll be returning our engine. Insert. And public function. Delete, yeah, and we will be returning our engine delete. Is it? Yeah. So now if you want to make things extremely abstract, which I won't go into, you could bring in the factory pattern here, because this particular structure we have made extensively support the factory pattern. So which type of database engine do you want to bring? We know maybe you might want to bring an SQL engine, or you want to bring a NoSQL engine. You can actually make that on the fly. So let's say you could have an engine factory, maybe a database engine factory that actually creates the type of engine you want and returns that engine, and then we just plug in the engine into the engine client and boom. But with the we are just going to, should we hard code, or should we make it more flexible right now? Okay, so up to now we are just still working on the engine itself. We have not even started the actual code, but just mean the actual code will be really simple to implement. We just need to get some things clear here, because afterward I will probably use some of these concepts in my other projects. That's what happens, right? And when I'm using them, I actually don't want to come and rewrite the whole thing again from scratch. So like I said, I probably will. So I probably Okay, so yeah, let me see what I have here. Yeah, good, good, good. With this, I can. So probably I'll end this stream at 6:15. Uh, and yeah, so what we're gonna do, given that we already have our database engine client interface, we now, this, like for this kind of pattern, we know that this particular code would just be like a boilerplate code. We know that, hey, there is an engine specification, there is the engine implements what the specification says. The engine client looks at the engine specification and uses the engine. So that's what we are seeing here. This database engine client interface actually looks at the engine specification interface, and then the class that is the engine client, which is our database manager, now will go ahead to implement, um, not to implement, but to use the engine. This is basically us using the engine. So I want to return self here, so that maybe in the future you might want to do some method tuning. Let me just return this. Yeah, you might just want to set engine a query, something like that, so we can have method tuning possible. Yeah, yeah. So you can see this is actually using the engine. This engine update. The reason we are calling update, because we are very much aware that if there is update here, then there is update in the engine. If there is query here, then there is query in the engine. It's that simple. Now the thing is, the you will be thinking, so that means the manager is kind of coupled to the underlying engine. No, the engine itself is not even coupled. Um, so the type of engine with this particular update is defined by the database engine, not because the engine you will be using here can be an SQL engine or no SQL engine, but all of these engines implement this method here. So you see, there is really no coupling between the engine client. The engine client really doesn't have to know the actual type of engine. We can have an SQL engine, or we could have a no SQL engine. That's none of our client business. All of our client knows that, yeah, I can query that particular, the underlying database that the engine runs or operates. Yeah. So yeah, there's that engine stuff. I don't know where I took this engine name from, but I find it really cool. Yeah, it kind of makes things like you're mechanically engineering something. Okay, so given that we have our engine client, should we do something even more interesting? We can have the factories. So now, this is where we are introducing the factory pattern. Uh, should we really have factory? Hmm. The main reason I want us to have factory is because, let's say you have this kind of configuration file, and you want the system to work based on the configuration. So when the configuration changes, you want everything to change, yeah? So you don't want to hard code the creation of an actual engine. So we are saying, okay, I know very well that I can have so many types of database engine. I could have a MongoDB engine. I could have a MySQL engine. I could have a Postgres engine. Um, I could have let's say, Firebase database, yeah, Firebase real-time database. You can have an engine that is actually running that. So what if you want to create you want the application to use a particular database based on the specification of the based on some specification in the config file, yeah. Imagine you want to migrate your system. So you've gone around, okay, you have gone exactly to the SQL, the NoSQL engine, yeah. So you went to the NoSQL engine, you implemented all of these methods, update, delete, everything is working fine. You have tested it. Now you want every single object in your system to use this engine. So if you are to migrate data from your SQL to your NoSQL, you don't want to say, I want to spend time going through all of the code and changing things, and then I can migrate the current database. Yeah, I can migrate the current database, like maybe write a code to take everything from the current database and put it in the NoSQL database. You know, uh, before we start using the NoSQL database, you that could kind of waste the time. Let me say, and it's gonna be a little bit tough. So while you are writing a code that will just migrate everything to the NoSQL side, probably you could write a logic that says if we don't see the thing in the NoSQL database, then check the SQL database. So that kind of balance of so that means from now on, you change your configuration file such that the new engine is by default the factory will return um, is an engine of a particular type, maybe the Firebase real-time database or the Firebase Firestore engine. So it returns Firestore by default. So your objects now start saving their data on Firestore, and maybe it needs to query something, and when you ran the query, um, let's say, and the query didn't return anything, you could actually maybe um, come in here in the actual database manager now and say, okay, I want to save the return of this statement in an object, and if that object is empty, then go and query the other engine. So that means you could probably now generate, like, change the engine type here. You could save the current engine, you change the engine type and make a query to the SQL side, then return the data. So you see now, like, your whole migration from a single database type to another database type is based on a configuration file, and just a minor change to the layer between the actual engine and the clients that use the engine. So you see, that's why we want to have the factory. But then you could have a lot of factories in the future. You could have a lot of factories. You could have a user factory. You could have there can just be so many factories, and probably I just want to put these things in a factory namespace so that I don't have to worry about where my factories are. So a factory, the factory design pattern is something interesting. But now I'm thinking, how are we going to use the factory design pattern here? We know that the factory this is gonna be a database engine factory. Yeah, it's a database engine factory. It's not an engine factory. It's a database engine factory. You could even have a factory of factories. So you determine which engine factory are we returning. Are we returning a database engine factory? So probably let's say you have a single factory that's supposed to return any type. Okay, me, I'm just kidding now. I'm just having fun. So we could say, uh, I want to have this factory, but then this factory, like, actually returns any engine I want. Yeah, we can say any engine factory. So if it is an SMS, you want a particular SMS engine. If it is a database, you want a particular database engine. Um, if it is maybe some specific stuff, you want that specific engine. So you could have this engine that that returns returns not an engine. You could have this factory that returns um, a specific type of engine, but that factory uses the factory of factories, because to return an SQL to return a database engine, you need to use the database engine factory. But now, for us to get the database engine factory, we need a factory of factories, or like factory of factories that will return the factory we are supposed to use to generate the engine. So then you have a factory that generates some type of factories that generate other type of factories. So you're gonna have that kind of chain of factory generation until you reach down to the leaf. That's where we actually generate the real engine. So that's gonna be really cool, but I don't want to do that. But yeah, think about it. It's gonna be cool, eh? Let's say we're going to say PHP ZAS. This thing's supposed to end 6:15. PHP ZAS. We want to make um uh, huh, we know that our factory is a class, hmm? And it returns something that is of a type uh, database engine, yeah. So we can have a database engine factory. Um, so in the factory namespace, we could have factory that returns engine, like engine factories. Uh, we could have other factories that return things like, for example, the user, if you want a different type of user. Uh, or maybe you have types like shapes, yeah. You want to return different type of 3D objects, maybe a cone, or you want to return a sphere. You could have a shape factory that generates those different shapes. And so, since for me, currently it's like engines are a key part of the whole stuff. I'm going to have factory namespace, but then in the factory namespace, I'm going to have engine factories. So I'm going to have factory slash engine, and in this engine factory slash engine, we can all. What if we swap it? Our engine has a factory, so we say make class engine slash factory namespace, and then we have that makes sense. That makes a lot of sense. So we're gonna make class, yeah, make class. Do we need to have do we need to have an interface? Do we need to have an interface for factories that returns engine? An interface for factories that return engine clients? Because probably you might have different type of engine clients. You can have SMS engine clients, and but for now we don't have to make things complex. There is always copy and paste. When you see things getting hell out of hand, this is one of the reasons it becomes really hard to understand Java. Because Java, you see like a class that just has two lines of code, because these guys are following the solid principles very closely. Single responsibility X Y Z. So what I'll do for now, I'm going to just have I'm just going to have a factory that is a class. It's not going to be implementing any interface. Then we'll just make an engine factory. Hmm. It is complex a little bit. Okay. A database engine factory can return a type of database engine. So, do we have any method that we need to pass the factory itself as a parameter? Nah, I don't have any method that will need to do that. So I'm just going to say make engine, PHP ZAS make class engine in the factory namespace, and it's gonna be database engine. Beautiful. So we're gonna make uh, DB engine factory. I'm not going to say DB engine factory. I don't want to have very long name. DB engine factory. Does it do anything? Does it have a parent class? Okay, so what do all factories have in common? So that you can know that, you know what, if you're a factory, you're supposed to have this method. Should it be things like, what should it be? Should it be like so if there is a factory, this factory can return something of a type. You will say factory get a factory can return a particular product. An engine factory can return an engine. Um, yeah, an engine factory can return an engine. A user factory can return a user. I want to have a general name so that we don't have to worry about don't have to be worrying about abstracting things too much. If they come up, we will figure it out. Huh. It's just supposed to be a simple application. Mm, very simple. There you go. So in our factory namespace, we're gonna have DB engine factory, and DB engine factory should have a private constructor. I don't want you to create an object of DB engine factory. For now, probably in the future, we will be able to create an object. So if the thing is private, yeah, it's just private. You can't access it. So with that, I can leave it like that and just say, um, and say what? Get engine, yeah. So we can have public static function get engine. Now get engine, so we are supposed to return a type of database engine that is either SQL database engine or no SQL database engine, but really who cares? Now I'm thinking, what can we do so that we can return the type of engine we want? You know, if you have some configuration, it makes sense. So we can say, should it be string? Then we can put stuff in the engine constant, so we can have MySQL, different type of engines in there, different type of DB engines. Then we pass DB, yeah, like engine constants. Then we have DB engine constants. So we say MySQL DB, Firebase DB, Postgres DB. You know, that makes sense. So we're just gonna do string. It's gonna be string of engine type or engine name, let's just say, and this thing gonna return something of database engine interface. Yeah, like that. That's what we'll return. Hmm. Okay, expected type engine database engine interface. Expected type engine backslash database engine interface. Huh. Wait. Wait. We are in. Oh yeah. So there should be backslash here. It doesn't work. Okay, let me see. Oh, this thing's supposed to return a type of yeah, this one should not be here. It doesn't matter. It's just supposed to return a type of engine, yeah. So maybe for now we can just do some switch case, and this is a very simple engine name. You know, I like to deal with constants a lot. So I'm going to make a constant. Actually, this project is literally touching on almost everything we have done in so PHP ZAS make, but then we are going to be making a constant class, const class. So this one only holds constants, and it's going to be in the engine namespace, and it's called the engine constants. We have to have database engine constant, SMS engine constant, engine constants. The thing about constants is that we can inherit other constant classes. So just make this thing general engine constant, and then you can organize things in there based on what you want. Um, yeah. So at this point, I don't think I am reaching at the peak of really high abstractions, um, but it's not bad. Uh, it's not bad at all. We'll just manage like that. So we're going to be making a constant class engine constant, and what else? It's just gonna be engine constant. Wow. Oh, okay. I can I think I missed the stuff. It's not. Oh, it should be class const, not const class. Okay. It should just be make constant. Okay. I will update that thing. That's why I'm using it. Class consts. Yeah. So we have made engine constants. So we can go for the constants and see what we have. We have engine constants, engine.const. These ones are private constructors by default. So you can't, so you can put your constants up here. Okay. So I'm going to call this one constant. It's gonna be my SQL DB is equal to my SQL. Very simple. You can have different type of database name here. You could even put this thing in another more specific file, but it's up to you. I'm just gonna call it engine constant, engine type constant. Yeah, like that. And that's okay. So we're gonna say which engine are we gonna make? Um, we know that we are supposed to return a type of database engine, but the only database engine we have here is MySQL engine. So firstly, if there's no engine, if we can't return any engine here, we're going to return null. Yeah, we're going to return null. Oh, hmm, font null. Okay, we're supposed to return some engine. I'm just going to say case engine constants. Engine constants. What else? MySQL DB. Sometimes you want to do a little work when you are making your engine. It's up to you. We're just going to say return new. Set MySQL engine. Yeah, return new MySQL engine. Do we pass any parameter? No. So we can return engine database engine interface. And MySQL engine is implements the abstract. Hey, this makes sense. So you see, if we had more cases here, probably we could have no SQL, and then you want to return Firebase. That could work fine. So with our engine factory set, I don't like the way this thing doesn't put my fingers to like this, so that the next time we just add it there, just add it there. Oh, okay. Um, Okay. Wow. Wait. Don't tell me that we. Okay. The programming music finished. Eh? Oh. 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 Wait. You mean all this while you guys have not been seeing what I've been doing? Are you serious? Oh my god. I always make this mistake. Just forget that I'm supposed to change the screen. And I don't. Okay. So I've created this engine constants in the constants, and it has a what? Like, I'm so sorry. But anyway, no one has been here to tell me, hey, we can see your screen. But I'm sure in the future there will be some people around and we can do that. Yeah. So now we're good with our database thing. So finally today we finished the whole database setup, and we are about now to start doing the actual implementation. This has been a lot of abstractions, but so far so good. We're having a better structured system. Yeah. So I'm going to do I'm going to save it. So just do git add all git commit -m finished the database abstraction. Git push origin mean. Yep. So yeah, finally. Maybe I can say hi before we end. Hey. Yeah, I'm guessing you can see me. So yeah, this is. I am kind of done for today, and maybe Tuesday I will pick up from here, and yeah, we can see how everything goes. No, for me it's just fun when you have to abstract things, and I'm not going to forget about the conditional structure I'm going to create, so that you can pass. You can pass, conditional statements inside there. Um, it'll be something recursive. Something recursive. Okay. So with that said, I'll stop it here and see you.